Hello everyone, welcome to Sai Niketan online classes. In a previous class, we have discussed about maxima and minima, and also we have solved the exercise problems based on maxima and minima, right? So in this class, let us discuss about local maxima and local minima of a function. So what is mean by local maxima and what is mean by local minima of a function, right? So now we will start to explain the local maxima and local minima. So let us take the graph of the function. So here I will take the graph, right? So here x-axis, here it is a y-axis, and here it is a origin. Okay, now I will take the graph of the function like this. So this is the graph of the function, right? So this is the graph. This graph represents y is equal to f of x, right? So in this case, we have the sum of the points. So here I will call this is a this point is called B, this is the point C, and this is the point D, right? Now if you take the total interval, right, so if you take the total interval, this interval for the function y is equal to f of x, so in that case we are having the maximum value of this function at C. So this gives the maximum value of the function if you take the total interval, right? And if you take the point B, if you take the point B, this gives the minimum value of this function, right? So if you take the total interval, y is equal to f of x is a function defined on this interval. In that case, C gives the maximum value of the function y is equal to f of x, and B that gives the minimum value of the function y is equal to f of x, right? So now instead of taking this total interval, if I take the interval, or if I restrict the interval from C plus h to C minus h, so for this, so here I will take this one, so from this to this, right? So now I want to check the maximum value of this function in this interval, right? So here in that case, this point is called a local maxima. This is called a local maxima. And if I want to check the functional value of point B in this interval, in this case this is called a local minima. This is called a local minima. Then what is the meaning of local maxima and what is the meaning of local minima? So instead of taking the whole interval, if you take the value of this function at this interval, then this point is called a local maxima, and this is called a local minima, right? So now I want to check. Suppose here I will take the point x equal to C. Here I will take the point x equal to C. If x equal to C means here you are getting the functional value that is called f of C, right? So here x equal to C, now I will take the small interval, that interval I will represent h. So neighborhood of this point, the neighborhood of this point I will take here. In this case the value of x equal to C plus h, and the value of x, here I will take the value of x is C minus h. So in this case here you are getting f of C plus h, and here you are getting f of C minus h, right? Now we will see the nature of this function at neighborhood of this point, that point x equal to C, as compared to f of C plus h and f of C minus h. f of c is the maximum as compared to f of c plus h and c minus h. F of c is the maximum, hence this point is called local maxima of a function, right? So here I got the local maxima of a function. So when I am checking the functional value of the given function at the neighborhood of the function, suppose if here the value of x is equal to 2, so then here I am getting a 2.1. So this is one more point, the value of x equal to 2.1 and 2.2, right? So similarly here I am getting a 1.9 and here I am getting 1.99. So at the same time, so here also you are getting the functional values, right? At 2.1 also you are getting the functional value, at 1.9 also you are getting the functional value. As compared to functional value at 2.1 and 1.9, the functional value at x equal to 2 is the maximum. Hence it is called a local maxima. It means that, so at x equal to 2, the neighborhood of the point 2, they are 2.1 and 1.9. As compared to 2.1 and 1.9, the functional value at f of 2 is maximum. Hence this is called a local maxima. Okay. Similarly, here I will take, this is the point, here I will take the point that x equal to c, right? So at x equal to c, here I am getting f of c. This f of c here I called local minima, because at the neighborhood of point c, if you take one more point, that is x equal to c plus h, and here you take one more point, that is x equal to c minus h. As compared to the neighborhood point x equal to c plus h and x equal to c minus h, the functional value of point x equal to c is less. Hence it is the minimum, and this minimum value of the function, that is called the local minima, right? So x equal to c, here also if you take the 2 points, so here you take 2.1 and here you take 1.9, and here the value of x equal to 2. The functional value at 2.1 and the functional value at 1.9, the functional value at x equal to 2 is minimum. That minimum value will call the local minima. So therefore you should remember local maxima and local minima, that is related to the neighborhood point of x. So that is x equal to c plus h and x equal to c minus h. It means that locally, so in this local area we are finding the functional value of a given function, that is called a local maxima and local minima. Instead of checking the functional value at a neighborhood of x equal to c, in that case if you take the total interval, in that case you are getting the maximum value is c, the minimum value is b. But here you are checking the functional values at the neighborhood of the point c. In that case, here you are getting f of c, that is called a local maxima, and here you are getting f of c, that is called a local minima. So therefore you should remember local maxima and local minima, they are related to neighborhood of the point x equal to c. They are c plus h and c minus h. Comparing the functional values at c plus h and c minus h, which is a maximum, that is called a local maximum, which is minimum, that is called a local minimum. So now let us write the definition, right? Let y is equal to f of x be a function defined in the interval I. Then the first condition is the point x equal to c is called the point x equal to c is a point of local maxima local maxima if f of c more than f of x for all x belongs to. If you take x belongs to I, then that is called maxima. So here for all x belongs to the interval. Which interval here we have to take? That is c minus h and c plus h. Then f of c is the local maxima of f, and f of c is called local maximum value. So therefore f of c is local maximum value, and point c is called local maximum point. Okay, next we will go to the minima, right? So here the point x equal to c is point of a local minima if f of c less than f of x. For all, what is the condition? If here you take for all x belongs to I, then you are getting the local minima. So here what is the condition for x? For all x belongs to c minus h and c plus h, then f of c is the local minima of f, and the functional value, that is f of c, is called local minimum value. So this is about local maxima and local minima, right? So these are the mathematical definitions to know what is mean by local maxima and local minima of a function. Okay, now we are studying the applications of the derivative. Now how we have to use the derivatives to find the local maxima and local minima. For that we have the two tests. So they are first derivative test and second derivative test, right? Now let us discuss about the first derivative test and second derivative test. Okay, the next is first derivative test and second derivative test, right? So for this again I will take the one more graph of the function. So here I will take x, here I will take y, and here it is a origin, right? So now here I will take the graph of the function, so like this, right? So this is one graph. This graph is called y is equal to f of x, right? So and again here you are getting the maximum value. This is a point A, and here I will call this is a point B, and here you are getting the one more point, right? So to discuss about the first derivative test and second derivative test, so here you should know the two important definitions. So they are the critical points. So what is the meaning of critical point, right? So to know the meaning of critical points, or these are also called turning points, right? So here let us take the tangent. So here the tangent. So tangent is nothing but what? Suppose here you want to take the tangent, right? So tangent to this curve, and here I will take one more tangent. So this is the tangent, and in this case In this case, it is not possible to draw the tangent because it is a curve shaped. So here it is a edges is there. So here for edges it is not possible to draw a tangent, right? So here f dash of x is not possible. F dash of x is not possible, or f dash of x is not exist. So here I will write f dash of x is not exist. It means that, so in this point we are not going to draw a tangent, or if it is a edge shape graph is there, for this point it is not possible to draw a tangent. So in this case f is not differentiable, so in this case f is not differentiable. Okay, so hence I have not drawn the tangent, right? So here you should see, so if it is a x is there, so in this case what is the value of f dash of x? So clearly the value of f dash of x is 0, because f dash of x is nothing but it is a tangent, that is nothing but a tan theta. So in this case the tan theta is parallel to x axis, so therefore f dash of x equal to 0. And here I have taken one more tangent, so again here also we are getting a f dash of x equal to 0. F dash of x is nothing but it is the slope of the tangent. If the slope of the tangent is parallel to x axis, in this case slope of the tangent becomes 0. So in this point and in this point, so this is the point B, here I will call this is the point B, and here I will take the point C. So in the point A and point B, the slope of the tangent of this function is 0, and at the point C, so f dash of x is not exist. So then what is the meaning of critical points? So critical points means these are the points in which f dash of x is equal to 0 or f dash of x is not exist. So such a points are called critical points, right? So therefore the critical points means these are the points in which f has, so here I will write critical points. So these are the points in which, or at which, the points at which f dash of x equal to 0, or I will write at which either f dash of x equal to 0 or f dash of x is not exist. So such a points are called critical points of the graph, right? So the points at which either f dash of x equal to 0 or f dash of x is not exist, so such a points are called critical point. So in this graph A, B and the point C, they are called critical points. And also here you should observe, if it is a is there, so this is the value of x equal to c. If I take the value of x equal to c, and here I will take one more point, that is x equal to c. So clearly x equal to c, here you are getting a f of c, okay, and here x equal to c is there, again also here you are getting f of c, right? So see here f of c, that is a, and f of c, that is b. So clearly this is called a local maxima. This is called a local maxima, right? And this is a local minima. This is a local minima. So therefore the local maxima and local minima of a function is exist only when at the critical points. So in the critical points f dash of x is equal to 0 is there. So if f is having local maxima and local minima, only when for the only at the critical point. So therefore you should remember one more point. So if f has local maxima and local minima, if f has local maxima and local minima only at the critical points, only at the critical points, wherever the critical points are there, in that case we are having the local maxima and local minima, or f is local maxima and local minima, then only at the critical point. So f has a local maxima and local minima only at the critical point. So here you should remember these points, right? So now by using the critical points, now I will go to the first derivative test, right? So that is the application of the derivative to check the given function is local maxima and local minima. So we are going to discuss the first derivative test. Okay, right. So here I will write the first derivative test, right? So first derivative test. So this test we will use to say the given function is local maxima and local minima. So for this I will take the same graph. So here it is x-axis and here it is y-axis and here it is origin. So let us take the graph, right? So this is the graph, the function, right? So here I will take, this is a point A, this is a point B, and clearly A and B are the critical points. A and B are the critical points. So here I will write critical point, and here also we have the critical point, right? Now here this point f of c, or if here you take the value of x equal to c, here f of x is the local maxima, right? And here if you take this is x equal to c, then this is called local minima. Okay, local maxima and local minima. So then what is the first derivative test? So see here, so let y is equal to f of x be a function defined in open interval I, and x equal to c is the critical point. X equal to c is the critical point. Then the first condition, right? So the first condition, so see here, so this is a point A or this is a point C. Now I want to draw a tangent at the point neighborhood of this point A. Suppose if here I want to draw a tangent, suppose if I take the tangent, so here I will remove this one. So if here I want to take the tangent here, so this gives the tangent. So this is the tangent, means so clearly it is a f dash of x, right? So clearly this f dash of x makes an angle theta with the positive direction of x-axis, and this angle makes with the this tangent makes an angle theta, right? And this theta or this angle, that is a acute angle. So acute angle means clearly tan theta lies in the first quadrant. In the first quadrant tan theta is a positive. If you take f dash of x at the at neighborhood of c, here you are getting f dash of x is a positive. F dash of x is a positive. F dash of x is a positive means clearly more than 0, right? Now I will take one more tangent to this curve at the neighborhood of the point C, at here I will take one more tangent, right? So if I take the tangent here, right, so this is the tangent. So clearly this is f dash of x. So clearly this is a f dash of x. So here this f dash of x, if you want to extend this one, this tangent here, so again here the tangent which makes an angle theta with the positive direction of x axis, in that case here you are getting the obtuse angle triangle. So obtuse angle means, so clearly that lies in the second quadrant. So in second quadrant tan theta is a negative. Tan theta is a negative means, so clearly here you are getting f dash of x is a negative. So see here, so if you take the tangent, so left side of this point C, then you are getting f dash of x is more than 0. And if you take the tangent right side of the point x, in that case here you are getting f dash of x is a negative. So here you should observe that the sign of f dash of x is initially positive, after that it becomes the negative. It means that f dash of x changes its sign from positive to negative. The functional, if the sign of f dash of x from the sign of the function f dash of x changes from positive to negative, then in that case we are getting the local maxima of a function, right? So therefore here I will write, if the sign of f dash of x changes from positive to negative, right, as x increases through C, as x increases through the C, then f dash of x then f of x is the local maximum value of f, and the point C x equal to C is called a point of local maxima, right? So this is the first derivative test to say the given function is a local maxima. So for this, here just you should remember the sign of f dash of x changes from positive to negative as x increases through C, then f of x is a local maximum value of f, and the point x equal to C is called a point of local maxima. So it means that if you take the tangent as x increases, so here the value of x equal to C, as x increases to C, the sign of f dash of x, initially it is positive, again the value of x is increases through C, then the sign of f dash of x becomes a negative. So in this case, this f of C is called a local maxima, and x equal to C is called a point of local maxima. Okay, right. Now we have to discuss the local minima. So again here this is the point x equal to C. So again here you are getting the functional value, that is f of x. So here I will take f of x. So here f of x is a local minima. So here, so left side of this C, here you take one more tangent. So at this point here I want to take the tangent. So this is the tangent, right? So clearly this lies in the, or this tangent make an angle of theta with the positive direction of x axis, and clearly it lies in the second quadrant. In the second quadrant means that tan theta is negative. tan theta is negative means that is a slope, that is f dash of x is less than 0, right? Now I will take one more tangent at this point. So again this is the tangent. So this is the tangent. Again this tangent makes an angle theta with the positive direction of x-axis, and this angle is a acute angle. And if it is a acute angle means, so clearly it lies in the first quadrant. First quadrant, tan theta is positive. Therefore clearly positive means here you are getting f dash of x is more than 0. So clearly here you should observe the sign of f dash of x changes from negative to positive. So initially here it is less than 0. After that the sign of f dash changes to more than 0. So it means that the sign of f dash of x changes from negative to positive. In that case we are getting the local minima. So therefore the second one is, if the sign of f dash of x changes from negative to positive, as x increases through c, then f of x is local, a local minimum value of f, and the point x equal to c is called point of local minima. So this gives the local minima of a function. So for this, so just you have to check the sign of f dash of x. If the sign of f dash of x changes from negative to positive, then in that case we are getting the local minima, and f of x is called the local minima of the given function, and x equal to c means this is called the point of local minima, right? So in the third one, if the sign of f dash of x, does not change, then we are not getting the local maxima and local minima. So in such case x equal to c is called point of inflection. So in such case you are getting the x equal to c is called a point of inflection, right? So if the sign of f dash of x does not change, if it does not change positive to negative or negative to positive, in that case we are not getting the local maxima or local minima of the function, and also we are not getting the local maximum point or local minimum point. In such case x equal to c is called the point of inflection. So this is about the first derivative test, right? So first derivative test is helps us to find the local maxima or local minima of a function. If you want to find local maxima, just you have to check the sign of f dash of x from positive to negative. If you want to find the local minima of the function, in that case you have to check the value of f dash of x changes from sign of f dash of x changes from negative to positive, right? So this is called first derivative test, right? So in every time for a given function, it is a little bit lengthy to check the functional value or the value of f dash of x from positive to negative or negative to positive, this takes the lengthy process. So to avoid this one, we are using one more test, so that is called a second derivative test, right? So now we will discuss the second derivative test. Okay, second derivative test. Second derivative test. So then what is the, or how to apply the second derivative test, or what are the working rule to check the given function is a local maxima or local minima by using the second derivative test. So here let y is equal to f of x be a function defined in I, and x equal to c is a critical point. X equal to c is a critical point. In that first one is if both f dash of c is equal to 0 and f double dash of c is less than 0. If f dash of c equal to 0 and f double dash of c less than 0, then the function f is said to be local maximum value at x equal to c, and x equal to c is called point of local maxima. So this is the, instead of checking the sign of f dash of x from positive to negative, so here first we will check if f dash of x equal to 0 and f double dash of c which is less than 0, right? So less than 0 means f double dash of x we are getting the negative, then the function f is said to be local maximum value at x equal to c, and x equal to c is called point of local maxima. Okay, and second one is if f dash of c equal to 0 and f double dash of c is more than 0, then the function f is said to be local minimum value at x equal to c, and x equal to c is called point of local minima, is called point of local minima. Instead of checking the sign of f dash of x from negative to positive, here directly we will take f dash of c equal to 0 and f double dash of c which is more than 0. F double dash of c more than 0 means the second derivative of the function at point c, if we are getting the positive, then the function f is said to be a local minimum value at x equal to c, and x equal to c is called point of local minima, right? So in the third one, if both f dash of c equal to 0 and f double dash of c equal to 0. So when the first derivative at point c equal to 0 and the second derivative at the same point x equal to c is 0, then we say that test is fail. If we are getting the first derivative and second derivative at x equal to c, if we are getting both are 0, in that case we say that the test is fail. In that case again we have to go for the first derivative test to check the given function is having a maxima or minima, right? So as compared to first derivative test, so this is very easy to say that the given function is local maxima and local minima. So just you should remember all these points, and by using the second derivative test and also first derivative test, we will discuss the some of the exercise problems in next class. Thank you.